Okay, so there's nothing special about this particular orientation of the triangle. We could actually rotate this triangle around and put it kind of orient it on a different base. So we could kind of put it like that, where this is going to be B, this is going to be C, this is going to be A. So let's do A, B, C. And then our height would actually be measured right here. So this would be our H. So looking at it from this perspective, things are a little bit different. So in this case, you might want to do sine of C equals H over B. So in this case, H would be B times sine of C. And then we would be doing 1/2 base times height. And our base is now side A. So area is going to be 1/2 times A B sine of C. And, you know, there's one other way that you can orient this triangle, like this, with side B down here, C and A. This would be side A, side C, and side B. And then in this orientation, your height is over here. So in this way, you'd have sine of A is H over B, and so H is B sine A. And then you would get your area is 1/2 times the base C times the B sine A. So I'm going to write it as BC, and then times sine of A. So these formulas for area are all valid, and they just correspond to different ways that you could orient this triangle in space. You could, you know, flip it this way or flip it that way, set it on any one of the three sides, and you'd have a different height. It's called the height is called like the altitude of the triangle, and you get a different altitude depending on what orientation you're looking at. So it doesn't matter. They all give you the same. They'll all give you the exact same area. The formulas look slightly different, but you can see there's a pattern where it's taking 1/2 times two of the, times the product of two of the sides, and then the angle, the sine of the angle that's between those two sides. So just a quick example to put this to use. If you had a triangle and you went and measured, this is 10 inches. And this is 12 inches. And then you measured this angle and got 60 degrees. Okay, then you could calculate the area of this triangle by using the formula 1/2 times 10 inches times 12 inches, okay, and then times the sine of the angle between those two sides, sine of 60 degrees like this. And so then we would get, this would be like 5 times 12, so this would be 60, times sine of 60 degrees, which is the square root of 3 over 2. Yep. And then this would be like 30 root 3, which if you calculate that out here, 30 times the square root of 3, and you get about 52, if we round it, about 52 square inches for the area of that triangle. So this is a useful formula for finding areas of triangles when you don't have a right triangle, and if you want to get the area in terms of the side lengths instead of the height, right? If the height is not easily accessible to you for some reason, you can use this formula and get it in terms of area, in terms of sides and angles. So this is something you might use sometimes if you want to do sort of a substitution when you're doing like an application problem. You're trying to get things in terms of other things. It's just a useful relationship that you can lean on sometimes